I'm in the process of editing and reviewing the videos for the series, and I decided to record this as an extra part, just to make sure everyone knows how this Lookat constraints works. So let's just take a quick look. Instead of building using rigvops, I built everything using Apex, the same way I did the other examples. So here we are in example 5. It's very simple, just this, just this guy here, this point at the origin. Unfortunately, Houdini is not allow us to see the point, but it is there. And here I just transformed this point, rename it. So Lookat. Actually, this is Lookat, and this is Lookat up, because this one it's on top. Let's see all together. So here the Lookat, and here the Lookat up. And since I'm using the default orientation, because we don't have any parent-child relationship here, just a single point, and we don't have, or at least I didn't set any custom orientation. The axis of this transform is aligned to the default axis. And here I did things a little bit different, because I'm outputting both skeletons separately, here the base skeleton and here the guide skeleton. So I didn't add this joint to the guide skeleton. And again, since I wanted to build everything from scratch, I use this system to create the rest transforms. So it's not matching perfectly what I did here, but it works all the same. And if you take a look here at this constraint again, I'm using the system that I've been teaching in these videos. That's at least what I'm aiming for in my workflow, in my pipeline using Apex. So I'm setting the constraint using this input here. So I'm overriding the transform for this transform object. And here I'm using this Lookat constraint. And I've overridden this Lookat axis here, because the default is to use the opposite of this axis. So just simple stuff. There is nothing here because I'm using the default matrix. And here is the Lookat, let's say joint in general. So the Lookat will orient this main axis to make it look at this joint or this transform object. And then it will use this Lookat up as a secondary orientation or rotation that will make this outputted transformation to have the secondary axis to rotate around this primary axis. So that's the idea. Take a look that this axis is not aligned perfectly with this joint, because it makes in such a way that this is always perpendicular, but this will be in the same plane defined by this transform, the base transform that will change here. some point along the primary axis and this point here. So this plane, it will encompass this line as well. Let me just draw this very fast to make sure it's clear, the idea. So this is our base transform. It defines, among other things, position in space. If we get any position along this axis that is not the same as this will define a triangle. And this triangle will define a plane. If we extend this triangle in each of its sides. This direction here, this axis here, it is in the same plane as is this triangle. So that's what the Lookat constraint tries to do when orienting this secondary axis. It will orient it in such a way that this axis is always in this plane. So in other words, this direction here will intersect this triangle. So I hope it makes sense, because this is very important, since it will be the base not just for this piston constraint, but for the hexapods rig as well. So that's all for this video. Simple stuff. I hope it's clear enough. And next, we'll continue to start wrapping up the constraint or the rig for our piston.